If you had been alive during the age of the dinosaurs, 66 million years ago, you would have received no warning. There were no alarm systems, no evacuation shelters, and no way to stop the object racing toward Earth at nearly 20 kilometers per second. Within hours, the sky would blaze as if a second sun had appeared. The ground would shake violently. Vast forests would erupt in flames, while the oceans generated enormous tsunamis that spread across the planet. But the most terrifying part was this: the impact itself was only the beginning. So what really happened during the first 24 hours after the Chicxulub asteroid struck Earth? And what would a dinosaur living through that moment have seen, heard, and felt? Let's travel back to one of the most terrifying days in the history of life on our planet. Around 66 million years ago, near the end of the Cretaceous period, Earth was a warm world filled with life. Dinosaurs had dominated terrestrial ecosystems for more than 160 million years. In North America, Tyrannosaurus rex hunted through vast forests. Herds of Triceratops crossed open floodplains. Ankylosaurus was protected by a heavy layer of bony armor, while enormous long-necked dinosaurs, such as Alamosaurus, still roamed the land. In the sky, giant pterosaurs with wingspans, approaching those of small airplanes, continued to soar. Beneath the oceans, enormous marine reptiles such as mosasaurs remained near the top of the food chain. It seemed that no force was powerful enough to bring their age to an end. But far out in space, an asteroid estimated to have been between 10 and 15 kilometers wide was racing toward Earth. Chemical evidence found in the geological layer marking the KPG boundary suggests that it may have been a carbon-rich asteroid. It was nowhere near the size of a planet, but it may have weighed trillions of tons. More importantly, it was moving at an estimated speed of around 20 kilometers per second, more than 70,000 kilometers per hour. At that speed, once the asteroid was only as far from Earth as the Moon is today, the animals below may have had approximately 5 hours left in a normal world. Of course, the dinosaurs had no idea what was coming. At first, the asteroid may have appeared as nothing more than a small point of light, but as it entered Earth's atmosphere, it rapidly transformed into a blazing object. The air in front of it was violently compressed and ionized, producing an extremely bright trail of plasma. To any animal looking upward at that moment, it may have appeared as though a second, far brighter sun had suddenly emerged in the sky. A brilliant streak tore through the atmosphere, possibly accompanied by lightning-like electrical discharges. But almost no creature had enough time to understand what was happening. Only seconds after passing through the lower atmosphere, the asteroid struck a shallow tropical sea in what is now Mexico's Yucatán Peninsula. The collision released an almost unimaginable amount of energy. Scientific estimates vary, but the impact may have released energy equivalent to billions of Hiroshima-sized atomic bombs, exploding at once. The rock, seawater, and sediment at the impact site were instantly compressed, superheated, and vaporized. An enormous fireball formed and expanded outward for hundreds of kilometers. Every living thing close to ground zero had virtually no chance of survival. Dinosaurs, plants, soil, rock, and water were not simply burned. Much of the material was shattered, melted, or vaporized within seconds. The collision created the Chicxulub crater, which is approximately 180 kilometers wide. Today, most of the crater lies buried beneath layers of sediment, but its geological structure can still be detected beneath the Yucatán Peninsula and the floor of the Gulf of Mexico. Outside the area that was immediately destroyed, an intense thermal pulse spread across the landscape. Animals hundreds of kilometers away could have suffered severe burns. Dry vegetation began to ignite, and many forests near the impact zone were consumed by fire. However, the heat was only one of many deadly threats. When the asteroid slammed into Earth, it transferred an enormous amount of kinetic energy into the planet's crust. Scientists estimate that the impact may have generated seismic shaking comparable to an earthquake of magnitude 10 or possibly even greater. That would be far more powerful than any earthquake directly measured in human history. Seismic waves traveled rapidly through the ground. Within minutes, regions thousands of kilometers from the impact site began to shake. In less than an hour, the disturbance may have been felt across much of the planet. The ground could have moved violently enough to knock multi-ton animals off their feet. For large dinosaurs, a serious fall could have broken a leg or shattered their ribs. If an injured animal could not stand again, it would have had almost no chance of surviving the disasters that followed. Coastlines collapsed, landslides swept down slopes, and large bodies of water began to move violently. At the Tanis fossil site in North Dakota, more than 3,000 kilometers from the impact zone, scientists discovered an unusual deposit containing fish, tree branches, and material associated with the Chicxulub event. One hypothesis suggests that seismic waves caused rivers and inland bodies of water to surge back and forth like water sloshing inside an enormous container. This phenomenon is known as a seiche. Powerful waves may have swept fish and other organisms onto the shore before rapidly burying them beneath layers of sediment. While the ground was still shaking, a massive wall of compressed air was spreading away from the impact site. The rapidly expanding fireball pushed violently against the atmosphere, producing a high-pressure shock wave. Near the impact zone, the resulting winds may have exceeded 1,000 kilometers per hour. Even modern buildings would have been flattened by such force. But during the late Cretaceous, it was millions of trees and countless animals that stood in its path. Branches, stones, and other debris became deadly projectiles, carried by the wind at extremely high speeds. Animals that survived the initial thermal pulse could have been knocked down, buried, or severely injured by the pressure wave. As the shock wave traveled farther from the impact site, it gradually weakened. Even so, thousands of kilometers away, it may still have produced winds comparable to those of an extremely powerful hurricane. The sound of the explosion also continued to travel through the atmosphere. Pressure waves may have circled the Earth several times, similar to what has been recorded after major volcanic eruptions in modern history, but on a vastly greater scale. But what happened to the dinosaurs living on the opposite side of the planet? They may not have been killed directly by the fireball or the initial shockwave. For a short time, their surroundings may even have appeared relatively normal. But that did not last long. The impact launched enormous quantities of rock, dust, water vapor, and molten material high into the atmosphere. Some of this material may have escaped Earth entirely, but much of it quickly began falling back under the force of gravity. Within minutes of the collision, the fastest-moving fragments began re-entering the atmosphere. As they passed through the air at extreme speeds, they heated up and glowed. Billions of fragments may have filled the sky, creating something like an enormous meteor shower spreading across much of the planet. Not every region received the same amount of debris. However, the re-entry of this material may have produced a widespread pulse of thermal radiation, increasing the risk of wildfires and threatening animals exposed on the surface. The exact extent of global heating and the percentage of forest that burned remain subjects of scientific debate. Some models suggest that fires erupted across large areas of the planet. Other studies indicate that the heating was uneven and that some regions were affected far less than others. Nevertheless, soot and signs of burning have been found in geological deposits at many locations around the world. This confirms that large wildfires were an important part of the catastrophe. Animals living in burrows, deep water, caves, or behind natural barriers had a better chance of surviving the initial heat. This may help explain why small animals capable of hiding underground and eating many different types of food were more likely to survive than enormous species that required vast quantities of food every day. Within only the first hour, Earth had already endured a giant fireball, intense thermal radiation, an enormous earthquake, a powerful atmospheric shockwave, and material from space raining back down from the sky. If you have watched this far, tell MindNexus in the comments. If you had to choose one place to hide during this catastrophe, would you go deep inside a cave, dive underwater, or try to escape as far from the impact site as possible? Make your choice before we reach the next disaster. because not all of those hiding places would have been safe. The asteroid did not strike dry land. It crashed into a shallow sea. The impact displaced an enormous volume of seawater while violently deforming the seafloor, producing some of the most powerful tsunamis in Earth's history. During the first few minutes, water near the crater may have been forced upward into a colossal wall hundreds of meters high, possibly even higher close to the center of the impact. When the waves struck the coastline surrounding the Gulf of Mexico, they destroyed nearly everything in their path. Seawater, mud, rock, plants, and animals were carried far inland. Marine organisms that survived the initial heat and seismic shaking now faced sudden pressure changes, violent currents, and enormous quantities of sediment entering their habitats. Compared with seismic waves and atmospheric shock waves, tsunamis traveled more slowly. But in the deep ocean, they could still move at speeds comparable to those of a jet airliner. Modern computer simulations suggest that the Chicxulub tsunami was far more powerful than any tsunami recorded in human history. It spread through both the Atlantic and Pacific Oceans, reaching distant coastlines many hours later. Within the first 24 hours, coastlines around the Atlantic and parts of the Pacific may already have been affected. Far from the impact site, the waves were no longer hundreds of meters high, but they were still large enough to devastate coastal ecosystems. Ocean disturbances may have continued for several days. According to some models, it may have taken approximately 48 hours or longer for the tsunami's energy to spread throughout the world's ocean basins and begin to weaken significantly. Meanwhile, aftershocks continued to shake the ground. Extremely powerful earthquakes usually produce many aftershocks, and the Chicxulub Impact would have been no exception. During the following hours, the ground may have shaken again and again. New landslides occurred, trees weakened by fire, or the blast wave collapsed. Unstable caves and shelters may have fallen in, killing some of the animals that had survived the first stage of the disaster. Smoke, dust, and soot rapidly spread across the sky. Daylight changed into a dark red glow before becoming progressively dimmer. Areas affected by wildfires remained extremely hot. The fires consumed oxygen, produced toxic gases, and made it increasingly difficult for surviving animals to breathe. In sufficiently large fires, rising hot air can produce powerful winds and create localized weather systems. These events are known as firestorms. Near the impact site, conditions were even more chaotic. The Chicxulub crater did not simply become an enormous pit filled with volcanic lava. Rock was crushed, melted, and transformed under extreme pressure, producing a complex layer of superheated material. The unstable walls of the crater quickly collapsed inward. Seawater rushed back into the impact zone, where it came into contact with extremely hot rock, producing vast quantities of steam and intense hydrothermal activity. The upper surface may have cooled and hardened relatively quickly, but enormous amounts of heat remained trapped deep underground. The hydrothermal system beneath the crater may have remained active for a very long time on a geological scale. Some scientists suggest that these hot, mineral-rich environments may eventually have supported new communities of microorganisms. This shows how the same event that destroyed so much life also created entirely new ecological environments. The collision may also have influenced volcanic activity, but this possibility must be discussed carefully. At the time of the impact, enormous eruptions had already been occurring for a long time in the Deccan Traps region of present-day India. Some research suggests that seismic waves from the Chicxulub Impact may have altered or intensified certain phases of those eruptions. However, scientists continue to debate the exact relationship between the asteroid impact and Deccan volcanism. What is far more certain is that by the end of the first day, the dinosaurs' world had been permanently transformed. Large areas near the impact site had been completely destroyed. Vast forests had burned or been flattened by the shockwave. Coastal ecosystems had been devastated by tsunamis. Smoke, dust, and impact debris were spreading throughout the atmosphere. However, it would not be scientifically accurate to claim that every non-avian dinosaur died within the first 24 hours. Some individuals living far from the impact site, particularly those in well-protected environments, may have survived the first day. But their real struggle was only beginning. The rocks around Chicxulub contained large amounts of carbonate rock and sulfur-rich minerals. When these materials were vaporized, they released enormous quantities of gas and sulfur aerosols into the atmosphere. Dust, soot, and sulfur aerosols reduced the amount of sunlight reaching Earth's surface. After the intense initial heating, global temperatures began to fall rapidly. An impact winter spread across the planet. For months or possibly years, the amount of sunlight reaching the surface was severely reduced. Plants on land and plankton in the oceans could no longer carry out normal photosynthesis. Vegetation began to die. Enormous herbivorous dinosaurs lost their food supply. As herbivore populations collapsed, large carnivores could no longer find enough prey. Food chains on land and in the oceans began to fail. This may have been the process that killed many of the dinosaurs that survived the first day. Large animals were at a disadvantage because they required enormous amounts of food and reproduced relatively slowly. In contrast, small animals capable of hiding and surviving on seeds, insects, carrion, or many different food sources had a much greater chance of enduring the crisis. Some species of birds, direct descendants of theropod dinosaurs, survived the catastrophe. Therefore, from an evolutionary perspective, dinosaurs did not disappear completely. Modern birds are the only surviving dinosaur lineage. Along with the non-avian dinosaurs, approximately 75% of Earth's species disappeared during the KPG mass extinction. Pterosaurs, many marine reptiles, plankton species, and countless other groups of organisms were also lost. But the end of one age opened the way for another. As ecosystems slowly recovered, mammals began to diversify and occupy many of the environments once dominated by dinosaurs. Tens of millions of years later, one small branch of those mammals eventually evolved into humans. If the Chicxulub asteroid had missed Earth, or if it had struck a region with a different geological composition, the history of life might have followed a completely different path. Dinosaurs might have continued to dominate. Mammals might never have developed as they did, and humans might never have existed to study that distant and catastrophic day. In only a matter of seconds, an object just over 10 kilometers wide brought an end to an age that had lasted for more than 160 million years. But within the darkness of that mass extinction, the foundations of our modern world began to form. If you found this journey through the first 24 hours of the Chicxulub catastrophe fascinating, please like this video and subscribe to MindNexus for more explorations of the prehistoric world based on the latest scientific evidence. And tell us in the comments, which part of the dinosaurs' final day would have been the most terrifying? The fireball, the enormous earthquake, the megatsunamis, or the long impact winter that followed? Your answer may become the subject of the next MindNexus video.